welcome to the first session of this day. The speaker of this session is my colleague Robert Watson, who is going to talk about low bake powder coating resins technologies today. Hello, Robert. Good afternoon.
Hi, Daria. Hi. Nice to
Hi.
see you.
Don't forget to ask your questions in the Q&A part of this chat. And with saying that, Robert, I would like to hand over to you. Everyone, enjoy the presentation.
Thank you, Daria. And let me add my welcome to you all on this, our third day of the allnex Sustainability Conference. And we're focusing today on the theme of construction and infrastructure. As Daria mentioned there, my name is Rob Watson. I've been involved in powder coating resins and the powder coating industry generally for over 20 years in various technical and marketing roles. But what I'd like to do in the next 20 minutes is share some thoughts with you on how we see powder coatings and how powder coatings relate to the construction industry. We'll touch a little bit on where powder coatings have come from and very much where we think they're going. In my mind, there's absolutely no doubt that what is driving innovation within the powder coatings industry is sustainability. And I'll spend some time going through some key elements of where we see these drivers coming from and why they are so important. So let me spend a little bit of time on this slide here, which outlines the strategic priorities that we have within allnex, but what I see as being truly representative across the powder coatings industry. Now, the theme of my presentation is low bake powder coatings, but I'm going to touch on some of these other elements as well. But let me start from the left on this block and I'll work through. When we think about powder coatings, where they came from, they were originally designed to cure at 180 to 200 degrees centigrade, which is still very much the case. And that means that the substrate that was to be coated with the powder coatings is always metal. If it's metal, it can be powder coated. But when we talk about ultra low bake, we're looking at how we can drive down the curing temperature and get down to 130 degrees centigrade. And there's a lot of research intensity going into this effort. And the reason why powder coatings at 130 degrees centigrade is important is it opens up two avenues that weren't available before. One is that at 130 degrees centigrade, we can start to bring in the non-metallic substrates like metal, I beg your pardon, like MDF, like natural wood, plastics and coatings. And what this does, it enables powder coatings to have a greater reach. And it gives the applicator and the fabricator a wider choice of technologies than they currently have. So where they may have used a solvent-borne liquid coating, powder coatings can now come to the fore. And that's also brings the additional sustainability value proposition of powder, which is one, it's zero VOC, and two, the utilization rates are very high, which means the waste is very low. So it's a very powerful offering that powder can bring when we can come to substrates as well as metal. These are the thermally sensitive substrates, if you will. Now, the other element of low temperature cure, which has become much more important in the current energy crisis that we're experiencing, is if you can turn down the temperature of the oven where the powder coating is being cured, you save energy. And we think this is going to be a driving force for development of low temperature cure powders as we go forward. So I don't think the energy crisis is going to alleviate anytime soon. If we move along the block here and look at some of these other elements, next one is recyclables. And here we're talking about the circular economy, which has very much become a focal point in the sustainability discussion. And when we talk from the point of view of polyester resin makers for powder coatings, we're thinking about different building blocks that we can use for our polyesters. And in particular here with recyclables, we're looking at using plastic waste and more particularly recycled PET, the plastic bottles we use for our drinks and so on and so forth. And of course, what we're trying to do is fundamentally reduce our reliance on oil-based raw materials. And then that neatly brings us into the renewable story. And here it's very clear that we're trying to protect the Earth's natural resources. and we're trying to find alternatives to raw materials that have been derived from oil. And in doing so, enable us to reduce the carbon footprint of the resins that we make, and therefore reduce the carbon footprint of the powder coatings that those resins end up in. So recyclables and renewables together are two sides of the same coin, and it's about finding new building blocks that are more environmentally friendly and can help us along our sustainability journey when we're building polyesters for powder coatings. The final block that you'll see there, you'll immediately recognize regulatory is not just applicable to the coatings industry, it's across the entire chemical industry. And here we're talking about eliminating substances of very high concern. And specifically to us as resin makers, we talk about trimolytic anhydride, and we talk about the tin compounds that we use. But lately, in recent months, there's the debate around PFAS, the perfluoroalkyl components, which we're looking to eliminate from our bill of materials as well. So when you step back and you look at all four of these blocks, you get a very clear picture of how sustainability is driving the innovation. And as I mentioned, there's a lot of research intensity going into these elements. And certainly here with allnex, we're addressing all of these different elements, especially on the powder coating side. So let's now turn our attention to why powder coatings and construction. What's the link? Why is the link? And how does it look like? Because it might not be immediately obvious, but when we start to drill down, we see actually the two go hand in hand very closely. And when we think about construction, we can think about residential and commercial construction. So residential is single family homes, multi-family homes. Commercial construction, offices, hotels, restaurants, hospitality in general, industrial units as well. But there's also the infrastructure side of the story, which here we're talking about railway stations, airports, and so on and so forth. Now, when we think about construction, it starts with having the physical machinery to do the building. And in the middle of the top block there, there's the picture of the heavy machinery, the bulldozer digger there. And this is, we also refer to this as the ACE segment, agricultural construction and earth moving. You need those heavy equipment, that physical machinery to actually do the building, to excavate and to put the framework of the building together. And this ACE segment is a very important one for powder. So once you've started building and the building envelope starts to come out of the ground, we then have the various components that form that envelope. And here we can talk about the curtain wall, we can talk about the doors and windows, we can talk about the exterior cladding with its color and texture that gives life and vibrancy to a building. These are all very key market segments for powder coatings. But then once you've got the envelope of the building constructed, you need to put in the facilities and the amenities to make it suitable for human habitation and use. So you have the heating and ventilation section. So this is the HVAC. And then you can imagine putting kitchens into buildings, whether they be the residential or commercial or hospitals or hotels, whatever they may be. You need the domestic appliances, and this is another major segment for powder coatings. So, and what I do when I'm looking at the evolution of the powder coatings market, I always look at construction as an indicator for how the powder coating market may perform. If construction is doing well, I can expect powder coatings, the industry to do well. If there's a dip in construction, I can expect a dip to follow in powder coatings. So the two are very closely linked indeed. And if I look here at this pie chart with the particular market segments of powder, you can see all those elements that we've just been talking about showing up here. So one of the major segments there at 34% is the architectural extrusions. These are what are used for the curtain walls and the door frames and the window frames, for example. It will also find use in the roofing systems, the tiling systems. You can also imagine conservatories, which are made of aluminium extrusions as well. There's then this big segment of general metal, which is kind of a catch-all, but in here you'll find things like light fittings, you'll find fencing, you'll find balustrades, all these additional metallic components that find their use, or can find their use, in the construction industry. Then you can see appliances there is a big section at 15%. Metal furniture, you build an office, it needs equipping with furniture. So again, there's an indirect link between construction and where powder can fit in when we think about metal furniture. And then there's a section there for the heavy vehicles, the A segment standing alone at 5%. So there's very, very strong connectivity between construction and the market segments that powder feeds into, and those two are linked very closely together. So that's set the scene for powder coatings, where they sit, how they play, where they've come from a little bit. Let's take a look now at the low temperature cure journey that powders have been on. And let's take a look at the evolution and see where powders have come from. As I mentioned earlier, in the late 60s, early 70s, when powders were first developed, they were designed to cure at 200, 180, 200, and they very much still do. Now, what's important to remember is the role that the cross-linker plays in the achievable cure temperature. And we can almost think of a chemical dance. We've got the two partners, the cross-linker and the resin. And you can imagine that if one of those partners gets a little bit old and a little bit slow, then the dance becomes a little bit old and a little bit slow. And it's important to note that within the powder coatings industry, there hasn't really been any significant new cross-linker developed for about 30 years. And that last one was hydroxyalkyl amide, HAA, which is a very important cross-linker for the European market. But what we can say is that within the constraints of the curing chemistry that's imposed by the crosslinker, the resin industry has done a great job of designing resins that can cure at lower temperatures and really pushing the envelope of what's possible within the chemistry. So with HAA, we can get down to 160 degrees. With TGIC, another important crosslinker, triglycidyl isocyanurate, we can get down to 150, even 140. And when we cross-link a polyester with an epoxy resin, the so-called hybrid powder coatings, we can get down to 130. But as we move through the generations and we come to this particular decade, 2020 and beyond, we're looking to get powder coatings below 120 degrees centigrade when we can really start to penetrate these alternative substrates. But the key point to remember through all of this development as we drive down the curing temperature is these key properties that I mentioned on the right. You have to be able to achieve all gloss levels, the flow and appearance has to be there. You have to, as well as texture, you need smooth. You need the physical performance, so this can be mechanical or weathering durability. And the last one, which is slightly less tangible, is storage stability. The powder coating has to be able to be stored before it gets used without clumping and becoming unusable. So let's just delve into these low curing technologies a little bit further. And I've got some examples here. So this first one is an example of hydroxyalkyl amide. Again, very important for the European market. And we're showing here that it's possible to have HAA cure at 160 degrees centigrade, range of polyester cross-linker ratios, different types of polymer, whether it be a general industrial type polymer where there's no weathering specification, or standard durable, super durable, that architects put specifications on the coating to have certain weathering performance characteristics. And if we look on the right to see how some of these characteristics look, so this is a low gloss example with a gloss level of 26. The mechanical performance, direct, reverse, 40 inch-pounds, very acceptable for these types of polymers and coatings. The glass transition temperature, TG, is a good indicator of how storage stable a powder coating will be. And when we have a TG of 60, this is perfectly acceptable. And that last bar, the QUV, this is an example of accelerated weathering, and a typical pass is 300 hours to 50% gloss reduction. And we can see with this particular system that all those parameters are being met. So we can cure at lower temperature with HAA without any compromise in the performance of the coating. So this is a big step in the right direction. We can take triglycidyl isocyanurate and see the kind of examples we have here. So again, it's a standard durable polyester for architectural curing, outdoor applications. This particular one is a 93:7 ratio. And over on the right-hand side, we can see that what we've got from the gloss level, it's a high gloss system we can see acceptable smoothness, acceptable distinction of image, but at the bottom we can see the mechanical performance. So this is an impact test where we hit the panel either direct or indirect. And when we get to a level of 160 inch-pounds, we're starting to see the substrate fail before the coating fails. So again, when we step back and we say, well, are our coatings meeting the performance criteria? We can say yes. So 140 degrees, it's possible to cure with TGIC without any compromise in the mechanicals. And this is a big step because as temperature decreases, it becomes more challenging to cure the powder coating and it becomes more challenging to keep smoothness in the powder coating. If we go to the next step, to 130 degrees centigrade, this is where we get into the realm of ultra low bake. And here, this is with a polyester curing with an epoxy resin. And there's examples across all the ratios that can be used. Typical applications are in domestic appliance and in general metal. But now we start to open up MDF and wood. And the key point here, if you look on the chart on the right, that middle bar of smoothness, PCI is a Powder Coating Institute test reference, if you like, from 1 to 10. 6 is absolutely what we expect to see with a powder coating that cures at 180 to 200 degrees centigrade. So to get that level of smoothness at 130 degrees is a real let's say achievement in what the technology can do. And just at the bottom bar there, the MEK resistance, this is a solvent resistance test, which tells us whether the film is cured. In terms of number of rubs, we look for 50 double rubs, which is a standard pass. So we can say for this type of powder coating, we can get exceptional smoothness at 130 degrees centigrade with no loss of cure and no compromising properties. So very exciting that the technology is able to routinely hit the performance criteria at these lower temperatures. Let me bring the presentation to a close with this final outlook of how we see powder coatings moving as we go forward into the future. So I think it's very clear that the link between sustainability and innovative drive. Absolutely no doubt that that's what's behind the advances that are being made in powder coatings and powder coating resins. And as a consequence, we're seeing this new generation of powder coatings emerge across all the market segments, bringing in this new segment for powder, the segment of wood and thermally sensitive substrates. And it's because we're able to reduce the energy of cure. And what I'd like to say at this point is, I mentioned earlier that there's been no new cross-linker chemistry brought to the market in 30 years. Within allnex, we're changing that. Where our research efforts into ultra-low bake cure are looking at alternative curing chemistries that allow us to break through that, I won't call it a glass ceiling, it's more of a glass floor of low temperature cure. And we're very excited about that. And there's a lot of effort and energy being put into that on by the technicians here at allnex. And that means we can get to new substrates, which means we give the applicator and the fabricator greater choice of technologies. We're eliminating the raw materials of concern, and with using recyclables and renewables, we're effectively decarbonizing the resins and powder coatings. Now, if you were able to join on day one of our conference, you would have heard my colleague David de Klerk, our head of sustainability, describe the complexity of achieving our sustainable ambitions. When I'm talking with David, when I'm talking with colleagues and partners up and down the value chain, I describe it that we're on a 1,000-step journey and we're on step 10, something like this. We've got a long way to go. But already we're starting to make the right kind of moves, the right kind of directional change certainly in powder coatings. And we're very excited to be on this journey and with the innovation that our teams are putting in to this technology. So with that, I would like to thank you for listening. I hope you found those insights useful, and I'd be very happy to take any questions that you might have.
Thank you very much, Robert, for presenting. And yes, we have some questions for you. Let me
Very good.
start with this one. Yeah. Um, what advantages and disadvantages do low cure powder coatings have versus two-part cures, like, for example, epoxies?
Oh, okay. So now we're rather getting into the um, comparing different technologies. So with this is kind of comparing polyester chemistry to epoxy chemistry. I think when we look at two-pack epoxies, well, first of all, you've got one pack and two pack. So in powder, you only have one pack. That's a fundamental advantage. But when we think about epoxies, these are especially capable in chemical resistance in high flow, and that was probably, I would say, the bigger advantage of epoxies over polyester. But I would say that's not necessarily a function of a liquid. That's more a function of the chemistry than a function of a liquid versus a powder. I hope that answers the question.
Thank you very much, Robert, for answering this one. What are the main challenges for low temperature curing powder coatings?
I think I touched on them. The main challenge with lowering the temperature of powder coatings is, can you achieve the cure? Um, and then by achieving cure, you then bring in, can you have the mechanical properties, the weathering properties, the flow and appearance? So they are fundamentally the main challenges. The main chemical challenge is making sure you have full cure, but that manifests itself in the performance of the powder coating. An additional point is the storage stability. When we have highly reactive systems, which is what these fundamentally are, their storage stability can suffer. So we have to keep a close eye on how we develop that as well. So they're the two main things: cure, full cure, and storage stability, I would say.
Thank you very much, Robert, for answering this one too. Are there any options to go below 130 degrees? And does wood substrate restricted to MDF? And how successful this application is so far?
Okay, and for me, that's the heart of the challenge to ultra low bake and to powder. So is there a possibility to go below 120? Well, what the systems I've been describing are thermal cure. Okay, so within thermal cure, we can routinely get to 130 degrees centigrade with hybrid coatings. But the chemistry that the allnex team are working on is fundamentally designed to hit 120 and below. And there are other chemistries that are available as well. One particular one is UV powder. So UV powders have been available again for 20 plus years, maybe even longer than that, I think. And these are capable of curing below 120 degrees centigrade, and they can cure very quickly. And the challenge with UV powder is line of sight cure. So you can cure very simple objects like a flat panel. So panels that are used, MDF panels that are used for kitchen cabinets would be an excellent example. But if you want to go to something more complex shaped, it's difficult to do it with UV. So there are technologies available. There's some success today with the thermal cure systems for sure, but there's more work to be done, and that's the work that's being done by the teams here in allnex.
Thank you very much, Robert, for answering this one. And we move to the next. Do you see low bake powder technology to be used in the coatings of cars in the future?
So let me answer that question like this. My ambition for the ultimate performance of powder coatings is to have them applied on interior automotive plastic. If you can put powder
Mhm.
on interior automotive plastic, then powders are really, really at the forefront of the technology. Um, At the moment, we see powders used routinely on aluminium wheels, absolutely routinely. They're used for underhood parts as well. So under the hood, under in the engine compartment, for example, brake calipers, suspension rings, this kind of thing. Um, and there are some manufacturers who use powder coating as part of the base coat. Not so many, but the fundamental property of powder coatings is they're extremely tough, which makes them very suitable for stone chip resistance. So some manufacturers will use part of their base coat will be a layer of powder, or maybe a ring of powder around the bottom of the vehicle, for example. So it's there. It's the major challenge, I think, for powder, but it's coming.
Thank you very much for answering this question. And we move to the next one. What is the shelf life of epoxy powder coating?
Okay, that would be a better question for powder coating manufacturers, but I would say that generally powder coating manufacturers will put probably a 6 to 12 month shelf life on their powders, but that would be something to ask more directly to a powder coating manufacturer.
Thank you very much, Robert. And we move to the next. Can a combination of thermal and UV, can it be used for bake or powder resin systems?
That's a nice thought, and I think the answer is yes. Um, I would also go so far to say to extend that a little bit further and say that IR heating can be used as well as thermal cure. So when we start to put a mixture of the curing technologies together, we start to see some interesting effects. I still think the limitation of when you have UV is this line of sight cure. I suppose if you took UV and 130 cure with some of these advanced thermally curing systems, there could be a synergistic effect that could be beneficial. Yeah, but I know that there are teams that are looking at that, and it tends to be more on the powder coating applicators where they're looking at UV plus thermal. Yeah.
Thank you, Robert, very much. And we move to the next question. How critical is the melting point and TG of the binder in achieving a low cure powder coating?
The So let me answer it this way. I don't think the TG is specifically important when we're considering the cure. Where TG comes into its importance is in the flow and the stability of the system. Ideally, for a low temperature curing powder, you want as low a TG as possible so the film can flow as best as possible at the lower temperature. But conversely, you want a higher TG in order to give you the greatest storage stability. So there's always a trade-off.
Thank you very much, Robert, for answering this. And we move to the next question, very interesting one. Hello, can you hear me?
Yes, I can hear you.
Okay, very well. Is it true that BMW or Mercedes use powder technology for clear coat or on some cars?
Now, I think Powder and I beg your pardon, BMW and Mercedes also, if I
Yeah.
remember correctly, some years ago, probably 20 years ago, were looking at acrylic powders for coating the body of cars. And I might be saying something out of turn here, but I think it's something like one of the bigger BMW models at the time. And that was looked at. Those production lines have since been switched back to liquid, away from powder. But it was looked at a couple of decades ago. Yeah.
Thank you, Robert. And we move to the next question. Does wood substrate restricted to MDF and how successful this application is so far?
Um, Today, MDF is the main wood source. Now, ideally, we'd like to get powder coating onto natural wood as well, but MDF has been the major source. And the story has stopped and start for powder on MDF. And the reason is this: it's related to the quality of the MDF. Um, Again, probably about 15, 20 years ago, powders were designed for MDF, but it wasn't successful. And this was related to the quality of the MDF. Now, MDF itself has improved. And I think it's probably safe to say that powder will be more successful on the higher quality MDFs. And this is because when the MDF is being heated to cure the powder, we're getting gaseous emissions, moisture emissions from the wood. So, but we certainly know of applicators around the world where powder is being applied to MDF with quite some success. Sometimes we're also seeing on the poorer quality MDF that a base coat will be needed, a primer coat will be needed before the powder can be applied. And this can be a liquid or UV base coat, doesn't have to be powder on powder.
Thank you very much, Robert, for answering this one. And we move to the next question. How is this? What is the storage stability of powder in tropical countries?
So you can imagine in tropical countries, the ambient temperature is higher. So powder coatings have to be designed with higher TGs to be suitable in those regions. And of course, we see it in Southeast Asia where powder is regularly used. When we think about ultra low bake, that will be a specific challenge for application into that area. And there may be a trade off with the energy that can be saved in an ultra low bake powder and having to have some refrigerative storage for powders in those particular tropical environments and yeah, hot ambient countries generally, I would say.
Thank you, Robert. And let's move to the next. Can powder coatings be cured with LED?
If there's LED UV, I would guess so. The UV powder coatings. I'm not so aware of LED lighting, and for sure, UV powder is only a very small niche within the powder coating market at the moment. So that might be a very niche development, I would think, for UV powder. But if there's UV LEDs, then yes, I don't see why not.
And the very last question for you, Robert. Do you have any experience on how low bake powder coatings perform against corrosion on steel?
That's a nice question. So there's a lot of work being done for powder coatings on steel, particularly edge coverage, to make sure that we can get good edge coverage and improve performance. Is there anything specific on low bake? I'm not aware of anything yet. A significant target for ultra low bake tends to be more aluminium. We can imagine steel will be important because another aspect of ultra low bake powders is when you have a massive metal part, usually made of steel, it needs to be powder coated if you can cure at a lower temperature. So that will be, I'm sure, a direction of investigation for low bake when suitable low bake comes out for application onto steel. Yeah,
Thank you very much, Robert, for answering this question. Thank you for your presentation, and thank you everyone
you're
for
welcome.
asking. In
Yes, thank
case
you
you
for
would
those
like
questions.
In case you would like to get in touch with Robert, you can do that by contacting them via email, scheduling a meeting with them, or just send a private message to Robert. Thank you very much again and see you in the next session. Bye, Robert.
Thank you, everyone.